Hi everyone, today my group want to present about wind turbine. There are 4 members. First is Nurulain, second is Amira, fourth is Mama Izami, and lastly Mama Haikal Iqbal.
A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike coal or oil, these resources is totally renewed each day. Blades mounted around a rotor catch the wind and translate its kinetic energy into rotational energy. The traditional windmill used that rotational energy to green wind or pump water, while in modern wind turbine, it turns a generator and creates electricity. Did you know small turbine offer up to 20 kilowatt and can be easily rated to operate effectively in most areas of the world? Approximately 60% of the Earth's surface has enough wind for small turbine to generate electricity. To design wind turbine, they have 4 impacts. The first one is number of blade shape, blade length, and tower height. Number of blade on wind turbine increases, aerodynamic efficiency increases. But in a diminishing manner, when we move from 2 blades to 3 blades design, there is an increased efficiency of 3%. But when we move from 3 blades to 4 blades design, efficiency gain is marginal. As we increase the number of lift, cost of the system increases drastically. Along with the mechanical design of blades also become a difficult affair with more number of blades. Blades should be thinner to be aerodynamically efficient, but blades with inner portion in root may not withstand bending stress induced due to axial and loose. So, generally wind turbine with 3 blades which can accommodate a thicker root are used. The next big factor affecting performance of wind turbine is shape and orientation of blade cross-section. A moving machine experiencing fluid flow is a different velocity than actual velocity. It is called or is relative or apparent velocity. Apparent velocity of flow is difference between actual flow and blade velocity. If this is the actual flow velocity, a rotating blade will experience an apparent velocity of this at particular cross-section. A close look at wind turbine blade revealed that it is having a foil cross-section from root to tip. The driving force of wind turbine is lift force generated when wind flow over such a flow. Lift force will be perpendicular to apparent velocity. Generally, lift force increases with angle of attack. Along with that, undesirable drag force also increases, while tangential component of lift force support blade rotation drag force opposite it. So, a wind turbine can give maximum performance when lift and drag ratio is maximum. This is called as optimum angle of attack. Airfoil cross-section are aligned in a way to operate at this optimum angle of attack. Even though flow velocity is uniform along length of the blade velocity increases nearly as we move to tip. So, angle and magnitude of relative velocity of wind varies along length of the blade. Apparent velocity becomes more aligned to core direction as we move to tip. So, there should be a continuous twist in blade, so that at every airfoil cross-section angle of attack is optimal. When condition can change at any time, so it is also possible to rotate wind turbine blades in its own axis in order to achieve optimal angle of attack with varying wind condition. This is known as pitching of blades, a clever algorithm which uses wind condition and characteristic of wind turbine as input govern that the pitch angle for the maximum power production. Next big factor affecting performance of wind turbine is length of the blade. Power extracted by the wind turbine varies according to this equation. So, it is clear that a longer blade will favor the power extraction, but with increases in blade length, deflection of blade tip due to axial wind force also increases. So, blind increase in length of the blade may lead to dangerous situation of collision of blade in tower. With increases in blade length, tip velocity increases. Noise produced by the turbine is strong function of tip velocity. So, it is not permissible to increase blade length of level limit. Other factor which goes against long blades is requirement of huge mechanical structure which leads to heavy investment. Most critical factor of wind turbine design is determination of proper tower height. Power input available for wind turbine vary as cube of wind speed. So, a small change in wind speed will have a huge effect on power production. A typical wind speed increase from ground level is shown in figure. So, from power extraction point of view, it is desired to have tower height as high as possible, but difficult in road transportation and structural design problems put a limit on maximum tower height possible. So, this is how we design our wind turbine. That's all the explanation of wind turbine as source of electricity. Thank you.